Ever look up at the night sky and just feel, like, minuscule?
Yeah. Well, what if I told you that everything we see up there, every galaxy, every star, even us, is actually tucked away inside something way bigger and way weirder?
We're talking cosmic scales here.
Exactly. And you know how much we love diving deep into these kinds of mind-blowing ideas. So today, we're taking a plunge into some pretty groundbreaking cosmology, all thanks to some recent observations from the James Webb Space Telescope. Actually, a huge shout out to you, dear listener, for sending us those fascinating articles on this.
Yeah, this deep dive is for you.
Exactly. We're going to unpack all the juicy bits and really get to the heart of this cosmic mystery. And it all starts with a really weird discovery. This unexpected bias in the spin direction of galaxies way out there in the distant universe.
So picture this. Laura Shamir at Kansas State University, he's using the James Webb Space Telescope, specifically its Advanced Deep Extragalactic Survey, JADES for short.
Catchy. Right. JLA allows the telescope to see a massive amount of these super faint, super distant galaxies. And Shamir focused on the direction in which 263 of them were rotating.
So clockwise or counterclockwise, like a bunch of cosmic clocks.
Exactly. And here's the kicker. Roughly two-thirds of these galaxies were spinning clockwise, while only a third were spinning counterclockwise.
Okay, I'm going to be honest.
Yeah.
At first glance, that doesn't seem all that earth-shattering. I mean, some spin one way, some spin the other. What's the big deal?
Well, the thing is, up until now, cosmologists always assumed that those spin directions should be pretty evenly split, like
Yeah.
close to a 50-50 distribution.
Kind of like flipping a coin, right? Heads or tails, it's a toss-up.
Exactly. So this significant imbalance, this preference for clockwise rotation, it suggests that there might be something more fundamental at play here, something that's messing with that cosmic coin toss. And Shamir himself even said that the cause isn't completely clear yet. But he's put forward two main possibilities, and they are wild.
All right, lay them on us. You mentioned one earlier that really blew my mind. The idea that the universe was, like, born with a spin.
All right, buckle up because this one's going to take you for a ride. Shamir's first explanation proposes that the universe from the very beginning had this rotational momentum, like a giant spinning top.
I mean, just picturing that makes my head spin a little.
And here's where it gets even wilder. This idea actually aligns with some pretty mind-bending theories out there, particularly this one called black hole cosmology.
Black hole cosmology. Sounds intense.
It is. It essentially suggests that everything we can observe in our universe, everything, is actually contained within the interior of a black hole.
Whoa, whoa, whoa. Our entire universe inside a black hole. That sounds like something straight out of a sci-fi movie. How is that even scientifically possible?
I know, right? It's one of those things that makes you rethink everything. But the crazy thing is, the math that describes black holes in the very early universe, it actually allows for this kind of scenario.
So instead of thinking of a black hole as just this, like, point of no return, this
Yeah.
ultimate gravitational collapse, we could think of it as a region where a whole new reality is born.
Exactly. And there's another idea called Schwarzschild cosmology, which takes it a step further. It proposes that our galaxy is inside a black hole, which itself is inside another universe, and so on. It's like those Russian nesting dolls, universes within universes.
Mind blown.
Right. It's heavy stuff. But let's get back to Shamir's first explanation. If the universe did start with a spin, it's totally possible that that initial rotation influenced how those early galaxies formed and ultimately which way they started spinning.
It's like giving a pot of soup a good stir. That initial movement is going to affect everything that happens in the pot afterwards.
Precisely. And speaking of mind-blowing connections, there's a report from space.com that delves into the idea that what we observe as black holes might actually be wormholes.
Wormholes. You're talking about those theoretical tunnels through space-time, right? Like shortcuts to other parts of the universe.
Yeah. Exactly. They're also known as Einstein-Rosen bridges. And this report suggests they might be connecting us to other universes entirely.
So other universes out there, just a wormhole away. That's wild. But wouldn't we be able to see them if they were that close?
Well, that's the catch. The whole point of a black hole is that its gravity is so strong, nothing, not even light, can escape. So even if these wormholes are out there, we wouldn't be able to directly observe what's on the other side. It's all hidden behind that event horizon.
So we could be surrounded by other universes, and we'd have no clue. That's both terrifying and amazing at the same time.
Welcome to the world of cosmology. But, okay, let's get back to those potential explanations for those spinning galaxies. We've talked about the universe possibly being born with a spin, but there's another theoretical physicist we need to bring into the picture here. a guy named Nikodem Poplawski.
And he's got some pretty wild ideas about rotating universes too, right?
Oh yeah, he's been all over this idea for a while now, and he's super excited about these recent findings from the James Webb because he sees them as potentially supporting this whole idea of black holes acting as cosmic nurseries, birthing new universes.
So what's Poplawski's take on those spinning galaxies?
Well, he's been saying for a long time that our universe might have actually originated inside a rotating black hole. And his idea is that the rotational axis of that parent black hole could have basically imprinted a preferred direction onto our newborn universe. And that preferred direction would then influence how those early galaxies started to rotate, leading to that clockwise-counterclockwise imbalance that Shamir observed.
So it's like our universe inherited a spin from its parent black hole, and that spin is still affecting how things behave on a cosmic scale, even billions of years later.
Exactly. It's like the universe still carries the imprint of its birth. Pretty mind-blowing, right?
Absolutely.
Okay.
So that was possibility number one, a spinning universe born from a black hole. But what about Shamir's second explanation? That one, I think, was something about our own Milky Way messing with our observations.
Right. This one's a little less cosmically expansive, but still super interesting. Shamir suggests that it might be the rotation of our own galaxy, the Milky Way, that's influencing how we see the spin of those far-off galaxies.
So it's like our own cosmic neighborhood is affecting our view of the wider universe.
Exactly. Remember, we're not just sitting still here on Earth. We're constantly orbiting the center of the Milky Way.
Like a giant cosmic merry-go-round.
Perfect analogy. Now, Shamir's idea is that this constant motion might actually be affecting the light that reaches us from those super distant galaxies. It's like trying to judge the speed of a car coming towards you while you're also driving. Your own motion influences your perception.
So a galaxy that's spinning in the opposite direction to our own orbital motion, its light might appear a bit different, maybe a bit brighter or slightly distorted. Could that lead us to misinterpret its actual spin direction?
That's the gist of it. Shamir thinks the velocity of the Milky Way's rotation might have a bigger impact on how we see these super faint, super distant galaxies than we previously thought.
So it's not that the galaxies are actually spinning differently, it's just that our own movement is skewing our observations.
Exactly. It's like looking through a slightly warped lens. And Shamir even suggests that if this is the case, we might need to seriously rethink how we measure distances in the deep universe.
Rethink distance measurements. That's huge. Wouldn't that have implications way beyond just figuring which way those distant galaxies are spinning?
Totally. If our cosmic measuring stick needs to be adjusted, it could potentially help us solve some other major puzzles in cosmology. Shamir specifically mentions these discrepancies in how fast the universe is expanding, and even this weird age paradox where some really big, really old galaxies seem to be older than the universe itself.
That doesn't make any sense. How can something be older than the thing it exists within?
Right. It's a head-scratcher. But if we recalibrate our cosmic ruler, some of these seemingly contradictory observations might start to make a lot more sense.
So, to recap, Lear Shamir and his research with the James Webb Space Telescope have uncovered this really weird imbalance in the spin directions of super distant galaxies.
And the possible explanations are mind-blowing.
On the one hand, we might be living in a rotating universe that was born inside a black hole. On the other hand, it could be that our own galaxy's motion is playing tricks on our observations, and we need to rethink how we measure the vast distances of the cosmos. Either way, we're dealing with some fundamental questions about the nature of the universe.
Absolutely. And what's really fascinating from your perspective as a listener is that regardless of which explanation turns out to be correct, this discovery really highlights how much we still don't know about the universe.
And how much our own perspective, our position within this vast cosmic dance, can affect what we see and how we understand it.
Exactly. This asymmetry in galactic spin, it's a real curveball. It forces us to question some of our most basic assumptions and opens up whole new avenues for exploring how the universe came to be and how it's structured. It's like we're constantly peeling back layers of an infinitely complex onion.
And who knows what other surprises are waiting for us under those layers. It makes you wonder, what other fundamental assumptions might we be clinging to that'll be challenged by future discoveries? What other known facts might turn out to be, well, not so factual after all.
That's the beauty of science, isn't it? It's a constant process of discovery and refinement. We make observations, we form theories, and then new discoveries come along that force us to reevaluate everything. And sometimes those discoveries lead to paradigm shifts, a complete overhaul of how we understand the universe.
And those shifts They can be unsettling, but they're also incredibly exciting. They remind us that we're still just scratching the surface of cosmic knowledge. And who knows what mind-blowing revelations await us just beyond the horizon of our current understanding.
Precisely. This deep dive, it's just a small taste of the mysteries that are out there waiting to be unraveled.
So if you enjoyed this exploration of the potential black hole universe and those mind-bending spinning galaxies, hit that like button and subscribe to our channel for more mind-expanding deep dives.
And don't forget to leave us a comment and tell us what other cosmic mysteries or scientific quandaries you'd like us to explore in future episodes.
We're always on the lookout for new adventures in the realm of the unknown.
Stay tuned, folks. The universe is calling.